Let us have a look at a working demo setup containing an AREG800A and a QAT100. A generic radar under test is used to display the simulated echoes. A more complex hardware-in-the-loop scenario, where the sensor data is compared to the simulated objects, is demonstrated later in the video. The QAT100, used as a front end, features up to 192 individual transmit antennas defining the direction of the echo. In this setup, only one line of the QAT100 is used. The instrument is fully controlled by the backend and does therefore not require direct input. The echo itself is generated by the AREG800A, which is the backend of the setup. The instrument features the capability to simulate multiple moving artificial objects, supporting more complex scenarios. A QAT-Z50 absorber tube is used to minimize the reflections from the lab environment. The setup features multiple ways of target generation, with the most simple one being called static mode. In the static mode, objects can be directly manipulated from the instrument's user interface. We can switch on and off the objects individually, change their range, their radar cross-section, their Doppler, and their angle of arrival. Alternatively, one can play back previously defined scenarios using the on-screen menu. We have a simple predefined scenario with an object moving closer to the radar under test. The most advanced echo generation relies on the real-time computation of echoes and reflections in a third-party software. In this example, we are using the Vector Dyna4 environment simulation to calculate the radar object's parameters. The calculated objects are transferred to the AREG800 via the open simulation interface and generated in real time. This realization shows a takeover scenario as it happens daily on the road. Depending on the requirements, the scenarios can be altered and adapted.